Hello students, welcome to the next subtopic of semiconductor chapter, and in this subtopic we are going to learn about the bipolar junction transistor. So in the previous subtopics we discussed with how we can convert the alternating current to direct current using the rectifier circuits, and the next thing we learned is the special purpose PN junction diodes. In that we understood the Zener diode. When it is connected in the reverse bias condition, it acts like a voltage regulator. And after that we studied photodiode. Again, the photodiode has to be connected in the reverse bias condition, and whenever a photon of particular frequency or energy is incident on the depletion region, so depending upon the intensity of light getting incident on the depletion region, the amount of that much amount of current will be flowing to the photodiode. Okay, and we understood the solar cell. The solar cell, when exposed to the solar energy, it will generate voltage across its terminal, and whenever it is connected across the load, it can be used to get a current. So it can be considered as a DC power source, the solar cell. After that, we studied the light emitting diode. When it is connected in the forward bias condition, the amount of forward bias current flowing to the light emitting diode results into the intensity of the light which is getting out from the depletion region. Okay, so now we studied the normal PN junction diode. So what we consider, this was what substrate. So this was suppose silicon substrate. To one side we dope with P type of semiconductor, to another side we dope with the N type of semiconductor, right? And thus we form a junction such that this is the structure of PN junction diode. This is the structure of PN junction diode. But what we get if suppose I consider the silicon substrate, again the same thing, the silicon substrate. Okay, and to this side, if suppose I dope with the P type of impurity, and also to this side, if suppose I dope with the P type of impurity, and in the middle of this, in between this P type, if suppose I dope N type of impurity, then I will get two junctions like this. I'm going to get two junctions. Okay, I'm going to get a two junctions like this, and this will be called as PNP transistor. This is called as PNP transistor. So this is a BNP transistor. I can say bipolar junction transistor. Bipolar junction because there are two junctions. Okay, so these are two junctions present in the transistor. That's why the name is bipolar junction transistor. So if suppose I consider the same silicon substrate, and this is the silicon substrate, and if suppose this side, both sides are N type, and in between there is a P type of semiconductor, then I will get the two junctions like this, and this type of transistor it will be called as NPN transistor. This will be called as NPN transistor. Okay, so now we are going to study the transistor part. Okay, so diode, it was used for the unidirectional flow of current. Unidirectional flow of current. The Zener diode was used as a voltage regulator. The photodiode was used in many applications. We have seen the applications of the photodiodes, also the solar cell, also the light emitting diode. What is the purpose of this transistor? This transistor, it is used like a switch. Okay, the transistor can be used like a switch on off. Okay, electrically, if suppose you want to make the system automatic such that automatically it should get on or it should get off, so that can be done by using transistors. Okay, so that can be done by using transistor, and after the second application of the transistor is it can be used as an amplifier. Okay, so transistor can also be used like an amplifier. Transistor, the use application of transistor, actually 90% of the transistor are used as a switch. It is used for switching purpose on and off, and because the power dissipation is more in case of the transistor acting like an amplifier, working as an amplifier. So that's why transistor as an amplifier, it is less used in the industries. More transistor is used as a switch. Okay, but it can be used in two ways. It can be used as a switch or it can be used as an amplifier. Okay, so let us now start with the new subtopic, that is the bipolar junction transistor. So what is a bipolar junction transistor? So a junction transistor, it is a semiconductor device having two junctions and how many terminals? Three terminals. So namely, if suppose I consider NPN transistor, NPN transistor. So there will be a one terminal for N, there will be one terminal for P, and there will be one terminal for N. Right? So junction transistor is a semiconductor device. So obviously it is made up of silicon substrate. So it is a semiconductor device having two junctions. So this is the one junction here. I'm having this. This is the one junction. This is the other junction. So there are two junctions in the transistor and three terminals. So these are the three terminals. The first terminal it is called as emitter. The another is called as collector, and the terminal in between emitter and collector is called as base. So there are three terminals of this BJT. I can say emitter, collector, and base. The current in the transistor it is carried by both electrons and holes. So since it is a semiconductor device, transistor is a semiconductor device. So in semiconductor, the current it is because of both free electrons as well as holes. So that's why the current in the transistor is carried by both electrons as well as holes. Hence, it is called as bipolar junction transistor. So that's why it is called as bipolar. Bi means two, polar means polarity means electrons and holes, and there are two junctions, and this is called as transistor. Okay, this is called as transistor. So, what transistor has three dope regions which form a structure with two back-to-back NP junctions. Okay, so transistor has three dope regions. So I can say this is the, suppose I consider this is the N type, this is the P type, again this is N type. These are the two junctions. So if suppose I look into one particular part, let me use some other color. So if suppose I consider only this much part, suppose I consider only this much part. So here is the junction present. Okay, so if suppose I consider this much part, so this is going to be N and this is going to be P. So this is nothing but a normal PN junction diode. Okay. Again, if I consider the another part, again if I consider the another part, like this much part if I consider, so what I will get is I will get this side is P and again there is a junction in between and this side is N. So how many diodes I am getting? Two diodes. That means one transistor it can be considered to be made up of two diodes. So a transistor has three dope regions which form a structure with two back-to-back PN junctions. So two back-to-back PN junction means there will be, so this is what diode looks like. So this is what P and this is what N. So this is diode number suppose 2. So this is D2. This is diode number 2. Diode number 1 it is connected like this because this is the P region of the diode. Now this P regions are common. So this is the diode D1 and this is the N region, right? So this is diode D1, right? So there will be terminals like this. This is the emitter terminal, this is the collector terminal, and there will be the base terminal like this. Okay, so a complete transistor it is nothing but the replica of two back to back. Back to back means like this. The diodes connected like this. Back to back PN junctions. So there are two types of transistor, namely NPN transistor and PNP transistor. NPN transistor it is widely used. Why? Because the mobility of electrons is more compared to the mobility of holes. So that's why NPN transistor it is widely used. PNP transistor it is less used. Okay. So NPN transistor it is quick in response. So all of you are requested to pause the video. You can draw the diagrams. You can write the things. Okay. So a transistor has three dope regions which form a structure with two back-to-back PN junctions. So there are two types of transistor. I can say NPN and PNP transistor. This is the circuit diagram. So this is the circuit diagram symbol of electrical symbol of a transistor. So see if the arrow it is towards the base, arrow it is towards the base. So base is positive. That is NPN transistor. In case of PNP transistor, So this is actually wrong given in the textbook. So this should be PNP. So you all of you note this down. This is NPN. Okay. See, base is negative. Here it is written base is negative. So base is negative, and see here it is written emitter is positive, collector is positive. Then also it is written here NPN, which was wrong. It should be PNP, and this is what NPN. So NPN. Okay. So all of you please do the corrections. This is the emitter and this is the collector and this is the base. Base is negative. So if it is PNP, then the arrow it is towards the base. Okay. And if it is NPN, then arrow will be towards the emitter. If it is NPN, arrow will be towards the emitter. Okay. Okay. So now moving to the next part. The structure of BJT it is like this. You can say this is the emitter, this is collector, and this is base. This is for NPN transistor, and this is for PNP transistor. So if you look at this area wise, if area wise we consider, so area wise, collector area it is more, collector area it is more compared to the emitter area, and the lesser is the base area. So base area is very less. Okay, so you can see this. This is the base. So area of the base is very less compared to the collector and emitter, and collector area is very high. Again, in this case, collector area is very large compared to the base area. Okay, so base area is very small. So area wise always base is very less and collector is very high, and the emitter area is between collector and base. If you consider the doping concentration, so which part emitter, collector or base it is heavily doped. So emitter it is heavily doped. The emitter it is heavily doped, and after that there is a doping concentration of collector, and the base it is lightly doped. So base it is lightly doped. Also, it has very less area. Okay, so always consider the base. It is at lesser part in the case of area. Also in the case of doping concentration. Okay. So what is the why the name emitter is there? Because it is going to emit the majority charge carriers. In the case of PNP, it will be the holes. In the case of NPN, it will be the electrons. Okay. So it is going to emit. Emit means the charges are going to move like this, charges are going to move like this. So why the name is collector? Because it is going to collect that charges which was emitted by the emitter. Okay, so this is what the purpose of the collector. So because since it has to emit the electron, the emitter has to emit the electron. That's why the doping concentration of emitter it is very high, and the collector has to collect and keep that electrons or keep that charges. That's why there should be a space requirement for the collector, and the area of the collector does it is very high. Okay, now the base is only just providing an electrical connection between the emitter and collector. So that's why the doping concentration of base, as well as I can say the area of the base, it is very small. Doping concentration is less. Also, the area is very small, right? All of you please note these things. So two diode analogy of the BJT. I told you that transistor can be thought to be two junction diodes connected back to back like this. So in case of NPN transistor, so if I consider the diode like this is the P type, this is the N type. Okay. So this is P type, this is N type. Again, this is P type and this is N type. So this is N, this is PNP transistor. Okay. So this is wrong given in the textbook. So this is PNP transistor. Right. Also, if you look like this, the structure. So this is the P and this is N type. Also, this is P and this is what N type. So so I can say this is NPN transistor, right? So this is NPN transistor. So all of you please do the corrections, right? So two transistors can be thought to be two junction diodes connected back to back. As I told you, if I consider this NPN transistor like this. If I consider this NPN transistor like this, so this side I can say this is one diode NP, right? So I can write this diode like this. I can draw the diode like this. So this is N and this is P. Right? Also this side I can say it is PN. So again I can draw a diode like this. So this is P and this is N. So if I draw the connection like this, so this is NPN transistor. This is NPN transistor. So this side is the emitter, this side is the collector, and below is the base. Below is the base. Okay, so the complete transistor, it can be taught that it can be considered that two diodes get connected back to back like this. Okay, so all of you please take these things, do the correction in the textbook such that you won't will be feeling any, you won't will read the wrong things. Okay, please do the correction in the textbook. So terminologies in BJT, the bipolar junction transistor, what are the various terminologies or what are the various definitions I can say it is used in the bipolar junction transistor? The first one is the emitter. So what is the emitter meaning? It is a thick, heavily doped layer. So I told you that emitter it is heavily doped, doping concentration of emitter it is very high. So that's why it is considered to be it is a thick and heavily doped layer. This supplies large number of majority carriers. Okay, in the case of NPN it will be electrons. In the case of PNP it will be holes for the current flowing through the transistor. So this is the purpose of the emitter. It supplies a large number of majority carriers for the current. Next is the base. Now since emitter is the thick, I can say base is the thin and it is very lightly doped. It is the central layer. So obviously base is always the central layer of the transistor. Next is the collector. So what is collector? Collector is on the other side of the base. So it is also thick, but the area is very high. Okay, it is also thick and moderately doped. Moderately doped means the doping concentration lies between emitter and base. Okay, its area is larger than that of the emitter. So area of collector is larger compared to that of the emitter and the base. Okay, base area is very less. So that's why it is written it is thin. So this layer collects the major portion of the majority carriers supplied by the emitter. So this layer, what it does, it collects. So that is the purpose of the collector. It collects the major portion of the majority carriers supplied by the emitter. So if suppose the emitter supplies 100% of the majority charge carriers, 100% of the majority charge carriers, the base will consume only 5 percentage and the collector will consume the remaining 95 percentage of the majority charge carriers. Okay, so this layer collects major portion means of 95 percentage of the majority carriers supplied by the emitter. Emitter was supplying 100% and this is consuming 95%. The collector also helps dissipation of any small amount of heat generated. So since the area of the collector is very high, I can say the collector it is responsible for the dissipation of heat energy also in the process if the heat energy is getting generated. You can pause the video, you can write the things. Okay. Next is the depletion region. We all know what is the depletion region. We have already understood the depletion region in the diode PN junction diode. So what is the depletion region? Depletion regions are formed at the emitter base junction and the collector base junction. So there are two depletion regions. So this is suppose NPN transistor I am drawing. Always I will consider NPN transistor because it is widely used. So this is NPN transistor. This side is always to be considered as emitter. This side is always to be considered as collector. And this is the base in between emitter and collector. Okay. Now, how many junctions are formed? There are two junctions. So the name of the junction is this is emitter base junction. So this is called as junction EB. Okay, and this is collector base junction. I can say this is CB, JCB. Okay, JCB is the collector base junction, and JEB is the emitter base junction. So there are two junctions. So that means there are two depletion regions. So depletion regions are formed at the emitter base junction. So there is an emitter base junction. I can say it is denoted by JEB, and collector base junction, which is denoted by JCB. Okay. Next is the current. So what is the current flowing through the bipolar junction transistor? So there are three currents in BJT, namely emitter current IE, base current IB, and the collector current IC. So emitter was giving you 100%. From this 100%, the base current was 5%, and the collector current was around 95%. So such that I can write the emitter current is actually equal to base current plus collector current. IE it is equal to IB plus IC. IE it is equal to IB plus IC. Resistance. So what is the resistance? The emitter base junction has low resistance while the base collector junction has very high resistance. So there are two junctions. So this junction, the input side, I can say the input side has very low resistance. So resistance is very low, while this side, the output side, that the collector base junction, it has very high resistance. The resistance of this junction is very high, while the resistance of the other junction is very low. So what is the note point here? The note point is in most common method of biasing. Biasing means applying voltage. I hope you remember the terminology biasing. Biasing means applying voltage. Applying voltage. So in the most common method of biasing a transistor, the emitter base junction is forward bias and the collector base junction is reverse bias. So emitter base junction, it is actually forward bias. Forward bias means negative has to be connected to negative terminal of battery, positive has to be connected to positive terminal of battery. So this will be called as the forward biasing of this emitter base junction, while the collector base junction is reverse bias. Collector base junction is reverse bias means this negative is connected to positive terminal of a battery and positive is connected to negative terminal of a battery. So if suppose this type of scenario, this type of biasing is done, in this case the transistor can be used as an amplifier. Okay, so in this case the transistor can be used as an amplifier. It can be used as an amplifier. Okay, so in most common method of biasing a transistor, the emitter base junction is forward bias and the collector base junction is reverse bias. We'll now study the working of the NPN transistor. Okay, so if you remember, you have to remember this note point. This note point is very important. Okay, the first junction, the input junction should be forward bias. The output junction should be reverse bias. If it is done, then only the 95% of the current will be going to the collector. Okay, so working of the NPN transistor. So first I will give you the idea here. So this is the suppose NPN transistor, N, this is P, and again this is N. Okay, this side is emitter side, this is the base side, and this is the collector side. So this should be forward bias. So forward bias means negative connected to negative, positive connected to positive, like this. And this side should be reverse bias, means negative is connected to actually positive, and the positive is connected to negative. Okay, so this is called as VEE. Why? Because this is the voltage to the emitter, and this is called as VCC. Why? Because it is the voltage to the collector. Okay, so what happens to this? Since this junction is forward bias, this junction is forward bias, and this junction is reverse bias. So as per the normal condition, there should not be any current flowing through the collector. Okay, but 95% of the current flows through the collector. So what is the reason behind that? We are going to learn that. So since it is the forward bias, I can say this is the negative plate and this is the emitter which is heavily doped. So this heavily doped emitter will again get more number of negative charges from the battery. Okay, from the battery of the power supply. Now this more number of negative, if suppose this forward bias voltage, if it is VEE, it is greater than 0.7 volts. If it is greater than 0.7 volts, that means it will cross the potential barrier and it will come to the base region such that the negative part, negative charges, it is present in the base region now. Now base is positive, which is made up of holes. Base is positive, that has holes as the majority charge carriers. So this electrons, it will recombine with this hole, and it will result into a small amount of base current. Why small amount of base current? Because the base is lightly doped. Also the area of the base is very less. So what happens is more number of electrons, it gets actually accumulated in the base region. Now what happens is these negative electrons, they find this positive plate, VCC, which is at high polarity. So they jump to the collector region. So all the electrons, they come to the collector region like this, and that's why the current, it will flow to the collector like this. So this is the collector current IC. Okay. So this was the emitter current IE, so I can say IE is equal to IB plus IC, like this. Okay, so let us now see with respect to the diagram. So the first one, you can say this is voltage across emitter and base. So this is emitter, this is emitter, and this is base. So the voltage across emitter to the base. This is negative, and this is connected to negative terminal of battery. The positive is connected to positive terminal of battery. That means this junction, it is forward bias. This junction is forward bias. Okay. So you can see these are many electrons. Many electrons means majority carriers are there. Suppose this is 100%. Again, you can see this is the many electron name is there. That means it will be 95 percentage in the case of collector. Or you can see this is the few electrons are written here. That means only 5 percentage of the electrons are present in the base region. Now this is the positive terminal which is connected to negative terminal of this semiconductor. So I can say this junction, it is reverse bias. So one junction is forward bias, another junction is reverse bias. Now what happens if suppose this VEB VEB, it is actually greater than 0.7 volts. So I apply VEB, and VEB, that means more number of electrons are getting accumulated across this emitter, because the emitter, it is heavily doped. Again, this negative polarity of the battery, it pushes this electron to the base region. And if suppose the voltage, it is greater than 0.7 volts, this electrons, it will come to the base region like this. It will recombine with the holes, and it will result into the base current. So this is the base current which will be flowing to the base, right? But since the doping concentration of the base is very less, also I can say the area of the base is very less. So this electron will not get any more further holes to recombine and form a current. So they will be standing in the base region only. Now this electrons will get this positive terminal of a battery, and it will get attracted towards the positive terminal of a battery, and because of this, the electrons, it will come to the collector part. So you can see this all thing, it is getting accumulated in the collector and base part. So this is the IE current which was flowing like this. It is getting divided into two parts. The first one is IB in the downward direction, IC in this direction. So I can say IE, it is equal to IB plus IC. IE, it is equal to IB plus IC. Okay. IE, it is equal to IB plus IC. Right. So this is what the current equation of the transistor. Emitter current is equal to base current plus collector current. Emitter current is actually 100%. Base current is suppose 5 percentage, around 5 percentage. If it is less, then it is a good quality transistor. Okay, so if it is lesser than the 5 percentage, that means the quality of the transistor is very high. And the remaining one is the collector current. So this is 95%. Ideal transistor, I can say collector current and emitter current both are 100%, and base current is 0. Okay, so this is all about the working of the NPN transistor. All of you can pause the video, you can write the things, you can draw the diagram. Okay, I am moving to the next slide now. Configurations of bipolar junction transistor. Now, configuration of bipolar junction transistor means bipolar junction transistor, there are three configurations because there are three electrodes. So this is collector, this is emitter, and this is base. Collector, emitter, and base like this. So the arrow, it is towards the emitter, that means it is NPN transistor. NPN transistor. Now, in order to connect it to the normal power supply means there will be one main supply and one ground. There will be one main and there will be one ground. So there is only one thing, there is one main and there is one ground. So what we have to do, we have these are the three terminals and we have to connect it to the two terminal power supply, right? So we have to make one terminal common between the two terminals. So if suppose the collectorate is made common, that will be called as common collector configuration. If base is made common between collector and emitter, it will be called as common base configuration. If emitter is made common between base and collector, it will be called as common emitter configuration. Okay. So the first one is common emitter configuration. Let us see what is common emitter configuration. So this is the emitter which is connected to ground. Okay. So whenever you can say in your syllabus, till your syllabus you can say whenever the emitter it is connected to ground, then it is called as common emitter configuration. Okay, so this is also the common emitter configuration because emitter is connected to ground. So this is NPN transistor common emitter configuration. This is PNP common emitter configuration. Next is common base. So what is the meaning of common base? Common base is base will be connected to ground like this. So this is the base terminal which is connected to ground. This is the base terminal which is connected to ground. So that's why it is called as common base configuration. Okay. So the emitter it is towards the base. That means it is PNP transistor. PNP transistor, and this is arrow it is towards the emitter. That means it is NPN transistor. Okay. So these are the common base configuration. Okay. PNP and PNP, NPN common base configuration. The next is the common collector configuration. That means collector will be connected to ground. So here you can see collector it is connected to ground. Okay. So arrow it is towards the base. This is PNP. Arrow it is towards the emitter. It is NPN. Common collector configuration. So among these three configuration, only one configuration is there in your syllabus, and you have to study that particular configuration in detail. Okay, and that is the next topic. That is the common emitter configuration. Okay, so this is the introduction to the transistor. All of you are requested to again watch this video if suppose you have any doubt. Okay, you have to remember this part is very important for from exam point of view. Okay, next topic that we are going to learn is common emitter configuration. Thank you so much all of you for paying attention. Goodbye. Take care. Bye bye.